Somewhere in the long dark between the stars, far past the last planet you could ever name, there is a single point of light no wider than a quiet city, turning over and over in the silence. It is not a sun, though it was born from one. It does not blaze across the sky, though it once did. It rests now in the deep, a smooth and faintly glowing sphere, holding more weight inside it than the sun holds, folded into a ball you could drive across in 20 minutes if there were any road that led there. Around it, space itself seems combed into delicate lines, the way iron filings settle into arcs around a magnet on a child's table. Those lines reach out for thousands of miles, invisible, threading the emptiness with an order so fine and so immense that the whole region of space seems to breathe in slow, magnetic patterns. This is a magnetar, and it is one of the strangest and most beautiful things the universe has ever made. You're floating far above it, watching from a safe and impossible distance, the way you might watch a lighthouse from a warm boat far out at sea. There is nothing for you to do here, nothing to reach for, nothing to solve, nothing to carry. The light turns, and you simply watch it turn. You've come a very long way to be here, further than light itself travels in 50,000 years, and yet it has cost you nothing and asks nothing of you in return. You may let your shoulders grow heavy. You may let the back of your skull sink into whatever is beneath it. The sphere will keep turning whether you hold your attention on it or not. And that is the first kindness of this place. You do not need to remember any of it. You do not need to keep score or hold the numbers or follow the thread from one wonder to the next. Let the facts move through you, the way warm water moves through cupped hands. Some of it stays, most of it slips away, and the hands are gentler for having held it. What stays, stays. What drifts off was never yours to keep. Tonight you're only here to rest beneath something vast and orderly and far away, the way you might rest beneath a great old tree without needing to know the name of every leaf. Let the mind go loose. Let the breath find its own slow rhythm, and let the turning light do the rest. The thing you are watching began its life as a giant, a star many times the mass of the sun, blue-white and roaring, burning through its fuel in a fraction of the time our own sun will take. Stars like that do not fade away gently. When such a star exhausts the last of the fuel at its core, the core can no longer hold itself up against its own enormous weight, and in a single heartbeat it collapses inward, falling from something the size of a planet to something the size of a small city in less time than it takes you to blink. The outer layers of the star are flung outward in a great bloom of light that can briefly outshine an entire galaxy of ordinary suns. But it is not that outward flash that concerns you here. It is what is left behind, sitting quietly at the very centre of all the scattered glory, a small, dense ember, the seed of everything that follows. The brilliant flash that lights up the sky in such a death is, strangely, only a sliver of what the collapse releases. Very nearly all of that energy escapes not as light at all, but as a vast and silent flood of the faintest particles in nature, the ones called neutrinos. They pour out of the collapsing core in an instant, and they are so reluctant to touch anything that almost the whole flood streams straight through the dying star itself, as though the matter were not even there. A few of those same ghostly particles, born in deaths like this one, are sweeping through you this very moment in their countless billions, through the room, through the bed, through your resting body, and you feel not one of them, as easily as light passes through a clean pane of glass. It is among the gentlest facts in all of nature that the most violent event a star can suffer pours out most of its fury in a form so soft and so shy that it slips through everything it meets and leaves it wholly untouched. The blinding light is only the small leftover. The true torrent goes by unseen, a silent tide of almost nothing washing through you while you lie quietly in the dark. What remains is a neutron star, and it is unlike anything you have ever touched. Imagine taking the entire mass of the sun, a furnace so large that more than 1 million Earths would fit inside it, and crushing it down until it fits inside the boundaries of a single quiet town. The matter that results is so tightly packed that the empty space inside ordinary atoms is squeezed almost entirely away. Down on Earth, the things around you are mostly emptiness. The floor beneath you is far more void than substance. But here, in this collapsed core, the emptiness has been wrung out like water from a cloth, and what is left is pressed into a smoothness more perfect than any mirror ever ground by human hands. So perfect is that smoothness that the tallest mountain on the surface of such a star might rise no higher than a few millimeters, less than the width of a fingernail. Gravity there is so overwhelming that nothing can stand up against it. The entire surface is pulled down into a sphere truer and rounder than any planet, any marble, any drop of rain. If you could somehow set a single grain of sand falling toward it from just above, that grain would arrive moving faster than you can easily imagine, and yet from your safe distance the star itself only turns, serene, betraying nothing of the colossal force sleeping in its skin. To feel just how dense this matter is, picture a single sugar cube, the small white kind you might drop into a cup of tea on a slow morning. Now imagine that the cube were made not of sugar, but of the stuff inside a neutron star. That one little cube, no larger than the tip of your thumb, would weigh about 1 billion tons. It would weigh as much as a mountain, as much as all the cars and trucks and trains on a continent, all pressed into a space you could close your hand around. You could never lift it. Nothing on Earth could hold it. It would sink through the planet as easily as a stone sinks through mist. There is something almost soothing in a number that large. It is so far beyond the scale of any worry, so completely outside the reach of anything you have to do tomorrow, that the mind simply lets it go and floats. Hold the size of this thing in your mind for a moment longer, because the scale of it is part of the wonder. The whole star is perhaps 12 miles across, small enough to fit comfortably inside the boundaries of a single city, small enough that if it hung in the sky above a town, it would not even cover the town it hung over. And yet inside that modest sphere is packed more material than the entire sun. A spoonful of it outweighs a mountain range. The contrast is almost dreamlike. The largest mass folded into nearly the smallest space, the heaviest thing imaginable made small enough to hold in the eye all at once. There is a kind of rest in that thought, the sense that even the most enormous weight the universe can muster has somewhere to settle, somewhere to be quiet and round and complete. Across the surface of that sphere lies a crust, and even the crust is a marvel. It is not soft and it is not loose. It is a thin shell, perhaps a mile or so deep, made of atomic nuclei locked into a crystal lattice of staggering strength, a kind of cosmic iron, packed and ordered, far stronger than any steel that has ever been forged. Below the crust, deeper in, the matter flows as a strange and frictionless ocean, a sea with no waves you would recognize, layered beneath that hard, bright skin. From the outside, none of this turmoil shows. The surface only gleams, smooth and sealed, a single perfect shell wrapped around an interior no eye will ever see. You're watching the calmest possible face of an unimaginable interior, the way the surface of a still pond gives no hint of the cold depths beneath it. The pull of such a place curves more than matter. It curves the path of light itself. So intense is the gravity at the surface of a neutron star that the rays of light leaving it are bent as they climb away, like a stream of water arcing as it leaves a fountain. The strange and lovely result is that if you could float close and look at one directly, you would be able to see slightly more than half of its surface at once. The far side, the part that should be hidden around the back, gently lifted into view by the bending of its own light. The whole little world seems to open toward you, showing you more of itself than its roundness should ever allow. But you do not need to drift that close. From here, far out in the safe dark, it is enough to know that even light leans toward this place and bows a little as it goes. The star you're watching turns, and as it turns, it sweeps its strange magnetism across the dark. Every neutron star is born spinning, because the great parent star was spinning too, and when something vast collapses into something tiny, that spin wins tighter, the way a figure skater pulls in her arms and quickens. So this little sphere, only a dozen miles across, rotates not over the course of a day, the way the Earth does, but once every few seconds. Some turn once in 10 seconds, some in 2, some faster still. Picture that, an object heavier than the sun, completing a full and stately revolution in the time it takes you to draw one slow breath in and let it out again. Out in the silence, with nothing to push against, it simply keeps its time, turning and turning like a slow beacon no one built. There is a curious thing about the rhythm these stars settle into. Though each magnetar is born spinning furiously, perhaps hundreds of times a second in its first moments, every one that astronomers have so far measured now turns within a narrow and gentle band. A full revolution somewhere between about 2 seconds and 12. Not faster, not much slower. A small window of unhurried time into which all of them seem to have eased. The reason is that fierce magnetic break. It grips the dark so firmly that a magnetar sheds its dizzying birth speed with remarkable haste, slowing in mere thousands of years to the calm and stately pace it will keep thereafter. So if you could line up all the known magnetars and watch them turn together, you would see no jangle of mismatched speeds but a kind of quiet chorus, each one wheeling round every handful of seconds, close enough in tempo that they might almost be keeping time with one another across the whole breadth of the galaxy. The wildest spinners in the sky have become, by the simple working of their own magnetism, among the most measured and even of all the turning things there are. And here is what sets the magnetar apart from all its cousins, what makes these few rare objects the most magnetic things known to exist anywhere in the universe. Every neutron star carries a magnetic field, but a magnetar's field is something else entirely, a field roughly 1,000 trillion times stronger than the gentle magnetism of the Earth that nudges the needle of a compass toward north. It is hundreds of times stronger than the field of an ordinary neutron star, and stronger by far than anything that has ever been made in any laboratory on our world. If you tried to write that strength as a number, you would run out of patience before you ran out of zeros. It is a magnetism so profound that it does not merely surround the star, it shapes the very fabric of the space around it, and it is the quiet engine behind nearly everything strange and wonderful that a magnetar does. That field is the reason these objects are so few. Out of all the countless stars that have lived and died across the long history of the galaxy, only a few dozen magnetars are known, a small and precious handful, scattered through the dark like rare gems in an enormous unlit room. Astronomers have catalogued only around 30 of them with any confidence, and each new one is a small event, noted and named and studied with care. You're not looking at something common tonight. You're looking at one of the rarest kinds of object the cosmos knows how to build, a thing so unusual that all of human science has found only a few of them in the whole reach of the sky. Far below you it keeps turning, indifferent to how rare it is, content simply to be itself in the dark, while you grow heavier and warmer and further from the edges of the day. The magnetism is not a faint thing you would need a sensitive instrument to notice. It is a structure as real and definite as the grain in a piece of wood. If you could somehow see magnetic fields with your eyes, you would find the space around this star drawn into great looping arcs, rising from one pole, curving far out into the dark and falling back to the other. The same simple shape a bar magnet makes in the iron filings on a schoolroom desk, the way they leap into their curving lines the instant the magnet slides beneath the paper. Now lift that picture off the page and swell it until each tiny iron whisker is a span of empty space wider than a world, written across thousands of miles, so strong that the fabric of that space seems stiffened by it, held in a kind of magnetic amber. The lines do not flicker or shift. They hold steady and enormous, hour after hour, century after century. The star sits at the centre of its own invisible architecture, a cathedral of force with no walls, and it has built every soaring line of it out of nothing but the way it turns, the way a spider spins a whole gleaming web from a single thread of itself. How strong is strong out here? An ordinary neutron star, of which the galaxy holds a great many, already carries a magnetic field that would dwarf anything on Earth. A field 1 trillion times beyond the gentle pull that swings a compass needle. And yet a Magnetars field is stronger still than that. Not by a little, but by 100 times, sometimes 1,000. Try to climb that ladder in your mind, rung by rung. At the bottom sits the small magnet on a refrigerator door, holding up a child's drawing. Far above it, the great machines of laboratories, straining at the very limit of what human hands can build. Higher still, the ordinary neutron stars already past anything we could ever make. And then, alone at the top, so far above the rest that the lower rungs vanish into haze, the magnetar, above the pulsars, above the steady spinning beacons, above every other magnetic thing astronomers have ever measured. When scientists arrange all the known magnets of the universe from weakest to strongest, the magnetar sits by itself at the summit, in a place nothing else has reached. And there it rests, untroubled by the height, simply being the most magnetic object in all of creation while you breathe slowly in the dark. For a long time, no one knew such things could exist. The idea was born not from a telescope but from a question, asked quietly by 2 scientists in the early 1990s, Robert Duncan and Christopher Thompson, who wondered what would happen if a collapsing star were spinning fast enough and stirring its molten heart hard enough to wind its magnetic field to a strength no one had ever dared to imagine. On paper, with patience and care, they followed the mathematics where it led, and it led them somewhere astonishing, to a new kind of star, one that did not yet have a name. The numbers said that if the churning electrically charged fluid inside a newborn neutron star stirred fast enough in its first few seconds of life, it could act like an enormous dynamo, amplifying the magnetic field again and again until it reached a strength the universe had never been known to hold. It was a bold thought, almost too bold, and for a while it remained only that, a possibility sketched in equations on a quiet afternoon, a shape glimpsed in the mathematics, waiting in the stillness to be either found in the real sky or gently forgotten. Many fine ideas end that second way. This one did not. The name came soon after, a small and perfect word stitched together from magnetic and star, magnetar. And then, in time, the heavens answered. An astronomer named Carissa Covello-II and her colleagues found a real object in the sky, behaving exactly as the equations had predicted, a faint, slowly spinning star, slowing in just the way a fierce magnetic break would slow it, glowing in just the way such fields would make it glow. The idea sketched on paper had a body now, somewhere out in the dark, tens of thousands of years of light away. A real thing of crust and field and slow rotation, doing in the sky precisely what the equations had whispered it might. The measurements matched the predictions so closely that the case became hard to doubt, and what had been a daring guess settled over a few short years into accepted knowledge. There is something deeply restful in that order of things, a thought, held gently and carefully and tested against the world, eventually finding its quiet match in the real and silent sky. The dreamers were right, and the dark had been holding the proof all along, turning patiently, waiting only to be noticed. What feeds this object is itself unusual and worth holding for a moment. Most spinning stars shine by slowly giving up the energy of their rotation, the way a flywheel gives up its turning. But a magnetar has a second, deeper well to draw from. The immense energy locked inside its own magnetic field, so vast that the field itself can power the star's glow as it very slowly unwinds. It does not need to burn fuel the way the sun burns through its hydrogen, hour upon hour in a furnace at its heart. It does not need to fall inward any further. The falling is long over. It simply rests in the dark and lets the energy stored in its own magnetism seep gently outward as light. the way warmth leaves a sun-heated stone long after the fire has gone cold, long after evening has fallen and the beach has emptied. Think of that stone in your hand at dusk, still giving back the day's heat to your palm. And now imagine a warmth that lasts not for an hour but for thousands of years, drawn not from any fire but from the silent tension of a field, a star lit not by burning but by magnetism alone, glowing softly on the energy of its own invisible architecture. And that glow, for the most part, is not the soft yellow of a candle or the white of our sun. A magnetar pours out most of its light as X-rays, a kind of light your eyes cannot see, but one that special telescopes in orbit can gather as easily as you might gather rainwater in an open bowl. To those orbiting eyes, a magnetar is a steady gleaming point in the dark, glowing in colours that lie beyond the far edge of the rainbow, past red and past violet alike, in light so energetic that no eye made of flesh could ever register it. It betrays its presence across thousands of light years by the patient warmth of that invisible shine, a beacon broadcasting in a language only certain instruments can read. Somewhere above the earth, even now, in the cold and the silence just outside the atmosphere, telescopes turn slowly towards such points of light and gather them in, hour after patient hour, counting the faint arrival of rays that set out from their star before the first human footprint was ever pressed into soft ground. And far below all of that careful watching, on a dark and ordinary night, in a warm and ordinary room, you let your eyes close. Most of these objects keep to the crowded lanes of the galaxy, low among the great clouds where stars are born and where giant stars live their brief, bright lives. The handful that astronomers have found lie scattered along the flat plate of the Milky Way, many of them halfway across the galaxy, so far that the light arriving from them tonight set out before the first cities were built, before the first words were written, before anyone had yet thought to name a single star. The light you would gather from one of them is, in a sense, a message from the deep past carried faithfully across the dark for longer than all of human memory, longer than language, longer than farming, longer than the oldest story any people have ever told. It set out across the void when the world was wrapped in ice, and mammoths still moved across the plains, and it has been travelling ever since, never resting, never slowing, crossing an emptiness so wide that the mind goes soft trying to hold it. And it arrives, at last, with nothing at all to demand of you. No task, no answer, no urgency, only a single moment of quiet wonder, freely given and then gone. It is worth remembering how few they truly are. For every magnetar, the galaxy holds many thousands of ordinary stars, living out their long, calm lives, and a great many quieter neutron stars besides. The magnetars are the rare exceptions, the unusual children of unusually massive parents, and their fierce magnetic youth is only a small chapter in the long life of a star. To find even one is a kind of fortune. The galaxy holds hundreds of billions of stars, wound into a great spiral wider than the mind can picture, and somewhere within it turn these few dozen rare objects, most of them hidden behind curtains of dust, most of them silent for ages to stretch. To pull 30 of them out of all that darkness, across the whole vast wheel of the galaxy, is like finding 30 particular grains of sand on all the beaches of a world, the slow harvest of decades of careful watching by people who will likely never see them with their own eyes, only in the faint signals that fall night after night into their waiting instruments. And yet, grain by grain, decade by decade, they have been found, each one a small triumph of attention, each one added gently to a list that grows only by ones and twos. The field is so strong that near the star it would do something almost impossible to picture. Down on Earth, an atom is a soft little cloud, its electrons spread in gentle spheres around the centre, free to drift wherever the cloud is roundest. Near a magnetar, that freedom is gone. The field is so commanding that the electrons are forced to line up along it, drawn out into long thin needles all pointing the same way, like grass combed flat by a wind that never stops. Matter itself takes on a new and stranger geometry, ordered and aligned where once it was loose and round. the whole substance organised by the field into a kind of grain, the very alphabet of matter rewritten. And it is worth saying plainly as you rest, this is not anything that could ever reach you. It happens only in the few thousand miles closest to the star's surface, far past where any planet orbits, in a place no living creature will ever stand. From your safe and impossible distance, it is only a fact to marvel at, never a thing to fear, a quiet revelation of how deeply the patient laws of nature can bend when the conditions grow extreme. Even a star as still as this one is not entirely without motion in its skin. The crust, that hard bright shell of cosmic iron, is held under enormous strain by the colossal magnetic field threaded through it, and now and then, after long ages of patient tension, a small region of the crust shifts, a settling no larger than the length of your arm, a fault that gives way by a fraction of an inch. On Earth we would call such a thing an earthquake, the ground giving a single shrug along some hidden fault. Out there, astronomers call it a starquake, a tiny rearrangement of an almost unbreakable surface, releasing in an instant the strain that had been building silently for centuries. And yet, on a body this dense and this fiercely magnetic, even so small a movement carries an extraordinary force, for the crust it disturbs is heavier than mountains and bound to a field of staggering power. A shrug almost too small to measure, on a surface harder than anything we know, can set loose a flash of light brighter than the sun gives in years, a great consequence born of a very small motion, far away in the quiet dark. When a starquake unsettles the magnetic field, the star can answer with a sudden burst of energy, a flash of X-rays and gamma rays sent streaming out into the dark. Astronomers have a fittingly gentle-sounding name for the objects that do this: soft gamma repeaters, stars that send out repeated, comparatively soft flashes of the most energetic light there is. For long stretches, such a star lies quiet, giving off only its steady glow, betraying nothing of what stirs beneath its crust. Then, without warning, it shifts, lets slip a brief bright pulse of high-energy light, and falls still again, like a sleeper turning once beneath warm blankets, before settling back into deep and even breathing. There is a tenderness in the name itself, soft gamma repeater. Soft because, by the violent standards of such stars, these are the gentler flashes. Repeater because they return now and then over the years. The bursts come and go on no fixed schedule, a slow and irregular rhythm written in light. No human eye will ever directly see. Recorded only by the patient instruments that wait, season upon season, for the star to stir in its sleep, and then settle once more into stillness. Most of these flashes are modest, by the staggering standards of such stars, but on rare occasions something far grander happens. Once in a great while, the magnetic field does not merely shift but reorganizes itself entirely, snapping into a new arrangement and releasing in a heartbeat more energy than our sun pours out across many thousands of years. Astronomers call these the giant flares, and only a few have ever been recorded. They are among the brightest single events ever to reach us from beyond the sun, and yet because their sources lie so far away, across the great gulf of the galaxy, all of that titanic power arrives here as something faint, distant, and entirely harmless, a whisper of light from an unthinkable depth. The very first of these great flares ever caught arrived long before anyone had a name for what made it. On a spring day in 1979, a sudden surge of gamma rays swept across the instruments of more than a dozen spacecraft scattered through the solar system, each one registering the same brief flood of light a few moments apart as the wavefront washed over them in turn. By comparing those small differences in arrival time, scientists could trace the direction the flood had come from, and it pointed back to a glowing cloud of gas in the Large Magellanic Cloud, a small companion galaxy drifting beside our own, a tangle of light left behind by a star that had exploded thousands of years before. Within that cloud sat the source, a slowly spinning star that would, in time, be understood as a magnetar, It was the opening note of an entire field of study, struck before the players knew the name of the instrument. For years afterward, the event stood as a lovely puzzle, a flash from a known cloud in a neighbouring galaxy that no one could yet explain, a question set gently into the record, waiting patiently for the answer that would come only much later. One such giant flare has become quietly famous among the people who study these things. Late in the year 2004, on the 27th of December, a magnetar known by the plane catalogue name SGR-1806-2 let loose the brightest of all the giant flares ever measured. The star lies roughly 50,000 light-years away, halfway across the galaxy from us, tucked near its crowded centre. The light from that single instant had been travelling toward us, silently and without pause, for 500 centuries. It set out when the last great ice age still gripped the northern world, when glaciers lay thick over lands that now hold cities, when the whole of recorded history was still an unimaginable distance in the future. All through the slow rise and fall of every empire that has ever been, that light was crossing the dark, neither hurrying nor slowing, holding its course across a gulf so wide that 50,000 years were needed merely to cross it. And then, on a single December day in 2004, after that immense and patient journey, it arrived, brushing the waiting detectors for a fraction of a second, delivering its ancient message and passing on. The flare was so bright that, for about a fifth of a second, this single star 50,000 light-years away outshone the full moon in the kinds of light that carry such energy. Consider that for a moment, slowly, from your safe and distant place. A star so far away that its light needs 50,000 years to cross to us, briefly burning brighter to the right instruments than the nearest large object in our own night sky. All of that, from a sphere only a dozen miles across, in less time than the blink of an eye. Hold the two ends of that thought together, gently. The nearest large light in our sky, the moon that has watched over every night of human history, briefly matched and surpassed by a single fierce pinprick whose light had been 500 centuries in the crossing. The moon hangs a short journey away, close enough that people have walked upon it. The magnetar lies halfway across the galaxy, and for 1/5 of 1 second, in the fierce colours of light, the far thing outshone the near one. Then it was over. The flare faded back into the star's steady invisible glow, leaving behind only the faint and widening ripple of the light it had loosed, spreading outward into the dark toward whoever might be watching. When such a flare erupts, the great field does something that sounds almost impossible. It catches and holds the fire. In the first instant, a searing cloud of light and matter blooms above the surface, hotter than almost anything in nature, and rather than flying free, much of it is trapped, snared within the loops of the magnetic field like a glowing coal cupped in an invisible hand. There it lingers, a captured fireball, cooling slowly over seconds and minutes while the star turns beneath it. And because the trapped cloud is anchored to the field, and the field turns with the star, the light that escapes comes to us in gentle pulses, bright, then dimmer, then bright again, rising and falling in perfect step with the star's rotation, as though the fading fireball were being shown to us and then hidden, shown and then hidden, with each slow turn. From the great flare of 2004, that pulsing afterglow could be followed for several minutes as it ebbed away, each beat marking one more revolution of the star. A fire held in a magnetic palm glowing down by degrees, counting out the rotations of its keeper as it cooled. When that ripple reached the earth, it brushed, ever so faintly, against the very top of our atmosphere. High above the weather, far above the clouds and the birds and the tallest mountains, there is a thin and delicate layer where the air is touched by light from space, and on that December day, the distant flare gave that layer the gentlest of nudges, a small, measurable shiver in the upper edge of the sky, registered by instruments built to notice such things. Down at the surface, where the world went about its ordinary evening, kettles boiling, lamps lit, children carried up to bed, nothing at all was felt. No one's sleep was troubled, no window rattled, no needle jumped on any dial that a person could see. It was a feather-light touch from halfway across the galaxy, a faint hand laid for an instant on the very top of the world and then lifted away, leaving everything below exactly as it had been, warm and unbothered and safe. What is perhaps most soothing is how briefly such fury lasts and how rarely it comes. A single magnetar might wait centuries, even millennia, between its great flares. For nearly all of its long existence, it does nothing dramatic at all. It simply turns in the dark and shines its steady invisible light, gathering strain so slowly that whole human histories could pass between one giant flare and the next. The drama you've heard about is the rare exception in an existence that is, overwhelmingly, one of uneventful turning, long ages of stillness, broken once in a very great while by a single breath of light. Picture the whole life of such a star laid out as a long, dark ribbon stretching across thousands of years. Almost the entire length of it is plain and unmarked, smooth as still water, just the turning, just the faint glow, just the silent gathering of strain in a crust that gives nothing away. And then, here and there along that immense ribbon, a single tiny spark, a flare, a starquake, so widely spaced that whole human civilizations could rise and fall between one and the next. The sparks are real, but the ribbon is mostly calm, and it is the calm, not the sparks, that tells you what a magnetar truly is. And in the moments after a giant flare, the star does something almost musical. The sudden release sets the whole body trembling, and that tremble shows itself as a faint, regular flickering in the light that follows. A ringing, as if the star had been struck like an enormous bell and were humming softly as the vibration died away. By listening to that ringing, captured in the slowly dimming afterglow, scientists can learn about the hidden interior of the star, the way the tone of a struck bell tells you something about the metal it was cast from, its size, its thickness, the alloy hidden in its shape. A heavy bronze bell answers low and long, a thin one rings high and quickly fades. So too the star. The exact frequencies of its trembling reveal what kind of matter lies beneath that impenetrable crust, matter that no instrument could ever sample directly. A struck bell, half a galaxy off, ringing in a register no ear could ever hear, its fading note crossing the whole width of the galaxy to carry word of what hides inside. A song of the interior, sung once, after a single great blow, and never quite the same twice. These flares are, in their own way, cousins to something far closer and far gentler, the flares of our own sun. On the sun, tangled magnetic fields sometimes snap and rearrange, flinging out light and warmth in the events that paint our skies with auroras. A magnetar does the very same thing, governed by the very same physics, only scaled up almost beyond comprehension, its fields so much stronger that a single one of its flares can dwarf the lifetime output of an ordinary star. The same simple law, magnetism storing energy, then releasing it when it shifts, plays out on a quiet morning above your head and in the fiercest object in the galaxy. One pattern, written both small and unimaginably large. For all of this, the ordinary state of a magnetar is silence. It is easy, hearing of giant flares and starquakes, to picture something restless and seething. But the truth is closer to the opposite. These events are so widely spaced in time, and so brief when they come, that if you could sit beside such a star and watch it faithfully across an entire human lifetime, the overwhelming likelihood is that you would see nothing dramatic at all, only the steady turning, the faint invisible glow, the long and even rhythm of a thing wholly content to wait. The fireworks are real, but they are rare punctuation in a long sentence made almost entirely of quiet, a single comma perhaps, in a paragraph thousands of years long. The violence is the exception, the stillness is the rule, and it is that stillness, far more than the rare flash, that defines what a magnetar actually is. Not a monster of the dark, but one of its calmest and most constant residents, turning quietly where almost no one will ever look. The turning itself does not stay the same forever. With every rotation, the powerful magnetic field acts like an invisible brake, dragging very gently against the surrounding space, and so the star spins down across the ages, its rotation lengthening by the smallest fractions of a second over thousands of years. A magnetar slows far faster than its quieter cousins, precisely because its field is so strong and grips the dark so firmly. Picture a great spinning top set turning on a smooth table, but a top so heavy and so perfectly balanced that it takes whole centuries to slow even a little. There is no friction with any floor out there, no air to drag against. The only brake is the magnetism itself. A child who watched it, and an old woman who watched it 80 years later would see to any ordinary eye exactly the same steady turning. Only the most patient measurement gathered across decades can catch the star easing toward a longer and longer rhythm, slowing the way everything slows in the end, but with a grace and an unhurriedness that makes our own clock seem frantic. And this fierce magnetic chapter, for all its drama, does not last. By the measure of the cosmos, a magnetar's intense magnetic life is remarkably brief, perhaps only 10,000 years or so of full strength before the great field begins to fade. 10,000 years sounds enormous against the span of a human life, and it is longer than all of written history, longer than any city has stood. Yet against the billions of years that stars and galaxies endure, it is the merest flicker, a single bright morning in a life that lasts a great age. Imagine the whole existence of such a star compressed into a single day. The fierce magnetic chapter, with all its flares and starquakes, would occupy only the first few minutes after waking. The rest of that long day, hour upon hour, would pass in the calm of an ordinary quieting neutron star. The magnetar burns most fiercely magnetic only while it is young in cosmic terms, in the freshness of its first dawn, and then it quietly mellows, the way a fire that roared and crackled at midnight settles, by morning, into a soft and patient bed of glowing coals that gives off warmth long after the flames have gone. When that magnetic youth has passed, the star does not vanish or fall apart, it simply becomes calmer. The field weakens, the flares cease, the X-ray glow dims, and what remains is an ordinary quiet neutron star, turning on in the dark for ages more, carrying only the faintest memory of the fierce magnetism it once held. There is a deep gentleness in that arc, the sense that even the most intense things the universe can make are allowed in time to set their fury down and rest. Nothing is lost in the change, the star is not destroyed or diminished. It simply lays aside the fierce magnetism of its youth the way a person, late in a long life, lays aside the urgencies that once drove them and finds in their place a quieter and steadier kind of being. The flares fall silent, the strain stops gathering, the crust, no longer racked by its own immense field, settles into a stillness it will keep for ages. The star does not end. It only grows calm and goes on turning in the dark, lightened of the great burden it once carried, unhurried and unburdened at last. There is a reason a magnetar glows warmer than its years alone would explain. An ordinary neutron star cools steadily after its birth, shedding the heat of its making and growing ever dimmer as the ages pass. But in a magnetar, the slow unwinding of that titanic field does more than power the occasional flare. As the field gradually decays, it pours a steady trickle of warmth into the crust from within, like an ember banked deep in ash that keeps a hearthstone warm long after the visible fire is out. So a magnetar stays hotter and shines a little brighter in its invisible colours than a plain neutron star of the very same age. The field is not only the source of its fiercest moments, it is also a quiet inner warmth, gently heating the star from the inside for as long as the great magnetism lasts. It is a comforting image to hold at the edge of sleep, a deep, slow warmth seeping outward through a solid shell, keeping the whole small world a touch warmer than the cold around it would otherwise allow, for age upon unhurried age. The reach of the magnetic field is so profound that it changes even nothingness itself. Empty space, you might think, is simply empty, but where a magnetar's field threads through it, even the vacuum is altered, made to behave a little like a faint and invisible crystal. Light passing through that region travels ever so slightly differently, depending on how it is oriented, as though the emptiness had grown a delicate grain, like the grain in a pane of old glass. This is something predicted long ago by the deepest theories of light and matter, a strange consequence of the laws that govern the smallest things, set down in equations decades before anyone could test them. And almost nowhere in the whole universe is the effect strong enough even to glimpse. Ordinary space, even near ordinary stars, stays simply empty, simply clear. Only here, in the immediate neighbourhood of a magnetar, does the field grow mighty enough to leave its fingerprint upon the empty dark itself. Light passing through carries away a subtle mark of having travelled that altered emptiness, and careful instruments, reading that mark, confirm what the old equations promised. It is a place so magnetic that nothing within reach is exempt from its touch. Not gas, not light, not the atoms themselves, and not even nothing at all. There is a stranger thing still that light can do close to such a star, something it does almost nowhere else in all of creation. A single particle of light, a lone photon, can split quietly into two as it threads the fiercely magnetized space near the surface, parting into a pair of fainter ones the way a single drop of water beads and divides, and two such fainter photons can just as gently merge again into one. Down here, light never behaves so. A beam crossing an ordinary room arrives exactly as it left, undivided and whole. Only in the immense field of a magnetar does the very stuff of light grow soft enough to break and rejoin, so that the thin skin of the star glows in a way no ordinary surface ever could. It asks nothing of you to know it, only that you marvel, drowsily, that even light itself learns new and gentler tricks in such a place, far away in the patient dark. Not every magnetar announces itself the same way. Each one, when found, has its own character, a particular pace of turning, a particular habit of flaring, a preferred band of colours, small quirks of behaviour that may shift across months and years. Some fall silent for long stretches and then stir, some are loud in X-rays and utterly mute in the radio waves that ordinary pulsars broadcast across the galaxy. Some surprise their watchers by doing both, or by switching from one behaviour to another over the years. They are not identical beads strung on a wire, but distinct individuals. The small catalogue of known magnetars is less a row of copies than a gallery of personalities, each one catalogued and studied and slowly, fondly understood. To come to know them is a little like coming to know a scattered handful of distant lighthouses along a vast dark coast, each one blinking out its own particular signal at its own particular pace, across an ocean far too wide ever to cross, familiar at last not despite their distance, but through long and faithful watching of it. The surface of such a star is not cold despite the freezing dark around it. It glows at a temperature of perhaps 1,000,000 degrees or more, hotter than the visible surface of the sun by a wide margin, and yet, because the star is so small, all that searing heat is gathered into a sphere you could walk across in an afternoon, if walking there were possible. From your safe vantage far out in the black, that searing heat is only a steady, distant gleam, the way the glow of a blacksmith's forge looks calm and even beautiful when seen from clear across a wide, dark field at night. Stand close to the forge and the heat would drive you back, redden your face, fill the air with the smell of scorched iron. But from far across the cool grass, with the night between you and it, the same fire becomes only a warm point of orange light, gentle to look upon, soothing even. So it is with the star. A temperature that would unmake anything that drew near arrives, across the unbridgeable gulf of space, as nothing more than a faint and constant shine, a hearth glimpsed from very far away on a cold and peaceful night. Beneath the hard crust, the heart of the star is stranger still. There the matter is thought to flow as a superfluid, a substance that moves with no friction at all, swirling endlessly without ever slowing, a perfectly smooth and frictionless sea. Threaded through it may be a kind of cosmic superconductor, carrying the great magnetic field through the interior without resistance, sustaining it across the ages. These are states of matter so exotic that on Earth they can be coaxed into being only in the very coldest laboratories, only in the faintest hints, only for the briefest of moments, with enormous effort and great delicate machines. A few drops of a frictionless fluid, chilled to within a whisper of the coldest possible temperature, are a triumph of careful science. Inside a magnetar, that same impossible substance fills an entire hidden ocean, miles deep, swirling and frictionless and endless, with no one to make it and no machine to hold it, simply there, by nature, turning quietly beneath the gleaming crust where no instrument will ever reach. The strangest matter we can barely make for an instant. The star carries within it always an unseen sea of the impossible, kept in perfect stillness beneath an unbreakable lid. Even the field itself is not entirely still within the star. Threaded through that solid crystal crust, the great magnetic lines drift very slowly through the rigid matter, migrating over thousands of years the way a stain spreads through stone too slowly for any eye to follow. This unhurried wandering of the field is thought to be one of the things that finally strains the crust past its limit and sets off a starquake. The lines, creeping through the hard shell across the centuries, gradually bending and stressing it until at last it must give. It is a strange thought that a magnetic field can move through solid rock as though through a thick and patient fluid. But on the timescales a star keeps, the crust is less a fixed wall than a very slow river. The field eases through it grain by grain, century by century, rearranging the deep structure of the star so gently that nothing seems to happen at all. And then, once in a great while, the slow rearrangement reaches a breaking point, and the star releases a single bright sigh before settling back to its imperceptible drift. To bring the strength of the field back to a human scale, scientists sometimes offer a small, almost playful comparison. A magnetar's magnetic field is so strong that, were one somehow placed at the distance of the moon, it could quietly wipe the magnetic stripe from every credit card on Earth. The card itself would be unharmed. Only the invisible pattern on its back would gently dissolve, the stored information slipping into blankness without heat, without violence, without a sound, the way an incoming tide erases the writing a child has drawn in wet sand. It is a strange and almost gentle way to picture such immense power, not as something that shatters or scorches, but as a force great enough to reach across the entire distance to the moon, and yet, at the far end of that reach, doing nothing more dramatic than calming a pattern back into smoothness, asking the world only to forget one small thing. Power beyond comprehension, with the lightest possible touch. Across all the decades that people have watched the sky in these energetic colours of light, only a small number of giant flares have ever been recorded. The very brightest of these events can be counted on the fingers of a single hand. Each one is studied for years afterward, turned over and examined from every angle, the way you might cup a rare and perfect shell found at the tide line, holding it to the light, marvelling that it reached you at all. They are not common occurrences, but precious, infrequent gifts from the deep, each arriving after a journey of tens of thousands of years, each adding one more quiet line to the slowly growing story of what these stars are and how they live. The flares cannot be summoned or scheduled. They come when they come, after their long crossing of the dark, and each is received as the rare arrival it is, a single faint line of news from a star that spoke once, long ago, and fell silent again. And there is a newer wonder, only recently understood. For years, astronomers puzzled over strange ultra-brief flashes of radio light arriving from far across the cosmos with no known source. bursts lasting only the briefest splinter of a second, gone almost before any instrument could register them, their origin one of the genuine puzzles of modern astronomy. Then, not long ago, one such flash was traced for the first time to a magnetar within our own galaxy, an object called SGR 1935, close enough in cosmic terms to be studied, a star that astronomers already knew. It was a small but profound discovery. It suggested that at least some of those mysterious flashes, reaching us from unimaginable distances, may be the work of magnetars after all, these same rare stars speaking in yet another voice, a voice in radio rather than X-rays. A long-standing mystery and a familiar object, quietly joined, and the dark, which had seemed to hold an unanswerable question, was found instead to hold one more thing we were slowly coming to understand. Stars like these, and the violent births that make them, have a hand in something close to home. When massive stars collapse and neutron-rich matter is flung into space, the conditions can forge the heaviest elements there are, the gold and platinum and silver that, ages later, settle into planets and into the rings on people's fingers. The very atoms that make precious metals so prized were assembled in the extreme furnaces tied to dying massive stars and the dense matter they leave behind. So the next time you notice a gold band catching the light on someone's hand, you might remember, drowsily, that its atoms were forged in the kind of cosmic upheaval that also leaves magnetars in its wake, assembled in an instant of unimaginable heat and pressure, then flung out across the dark to drift for ages before settling at last into the rock of a young world. The quiet wealth of the earth, the metals we prize and polish and pass from hand to hand, are the scattered ash of dying giant stars. The jewellery resting in a drawer beside you, and the most magnetic stars in all the sky, are distant cousins, born of the same deep fire, separated now by time and distance, but kin all the same. Whether a dying star becomes a magnetar, a quieter neutron star, or something else entirely depends in part on how heavy it was to begin with. Only stars within a certain range of great mass leave behind a neutron star at all. Lighter stars fade gently into glowing embers called white dwarfs, while the very heaviest may collapse further still. The magnetars seem to come from a particular kind of massive parent, and the path to becoming one is narrow. A star must be born heavy enough to collapse into a neutron star at all, yet not so heavy that it falls past that stage into something denser still. And then, on top of that, it must spin and churn in just the right way, in just the right first few seconds, to amplify its magnetism to so fierce a pitch. Most massive stars never thread that needle. They leave behind quieter remnants, or none at all that we would call a magnetar. Only a small number, born under just the right confluence of weight and rotation and timing, leave behind one of these fiercely magnetic hearts, which is why, of all the multitude of stars that have ever blazed and died, only a precious few magnetars exist for us to find. Astronomers cannot hold a magnetar or touch its field, and yet they can measure that field with remarkable confidence simply by watching how the star turns. By timing the rotation precisely, and then measuring how gradually that rotation slows from one year to the next, they can work backward to the strength of the magnetic brake that must be causing the slowing. The faster the spin winds down, the stronger the hidden field must be. It is a quiet kind of detective work, learning the strength of an invisible force 50,000 light-years away by patiently clocking the turning of a star, the way you might guess the weight of a pendulum only by watching how its swing decays. There is real artistry in that measurement. A magnetar's rotation might lengthen by only a fraction of a second over the course of many thousands of years, a change far too small to notice in a single night, or even a single lifetime. Yet by gathering observation after observation, season after season, building a long and faithful record, scientists can detect that tiny lengthening and read the field's strength from it. It is a practice built on patience above all, the willingness to return, again and again, to the same faint and distant point of light, year upon year, recording its turning with exquisite care, trusting that the slow truth will reveal itself in time to anyone calm enough to wait for it. There is no shortcut. The lengthening emerges only from the long accumulation of measurement, the steady building of a record that may outlast the careers of those who begin it. One generation of watchers hands the work to the next, and the picture sharpens by slow degrees. It is science conducted at the pace of the stars themselves, unhurried, faithful, content to wait as long as the waiting takes. And there is something quietly beautiful in that, drifting here at the soft edge of sleep. Before the famous flare of 2004, there came an earlier and important moment. In the late 1990s, a magnetar known as SGR-1900 produced a great flare of its own, one of the first ever caught in such detail. It was that event, and the careful study that followed, which helped confirm that these strange, slowly spinning, fiercely magnetic stars were truly the soft gamma repeaters astronomers had been puzzling over for years. Two mysteries, long held apart, were quietly shown to be one and the same. The theorist's magnetar sketched years before in equations, and the observer's puzzling repeating bursts, caught now and then by orbiting eyes, revealed at last as a single kind of object seen from two different angles. For years the two had been studied separately by different people with different instruments, neither side quite certain the other was describing the same thing. Then the careful work converged, and the pieces slid into place. There is a particular satisfaction in that kind of joining, a deep and orderly pleasure, the moment when two long separate threads are seen to be one thread after all, when the strange becomes a little less strange, and a corner of the universe that had seemed to hold two riddles is found to hold only one, patiently waiting to be understood. These stars may shape more than their own neighbourhoods. Some scientists suspect that when certain especially massive stars die, a newborn magnetar at the centre, spinning fiercely and pouring out the energy of its winding field, could help drive the explosion itself, adding its strength to the outward blast, helping to fling the star's outer layers into space with extra brilliance. If so, then a magnetar is not merely the quiet remnant left after a death, but in some cases a hidden engine within the death itself. Picture the heart of the explosion, the great star coming apart, its shells of gas hurled outward, and at the very centre, a tiny sphere already turning thousands of times, already wound with a field beyond imagining, pouring that energy into the expanding cloud and brightening it from within. The seed and the explosion, bound together in a single moment, the new star, in its first instant of life, helping to light the funeral of the old one that made it. Birth and ending, folded into one bright event, and then ages of quiet to follow. This hidden engine may account for some of the most dazzling explosions the universe ever stages. Now and then, across the great distances, astronomers catch a dying star that blazes far brighter than any ordinary one, a supernova outshining its planar-kin by 10 times or 100, glowing for months where others fade in weeks. One of the gentlest explanations for such brilliance is a newborn magnetar at the heart of it, spinning hundreds of times each second in its first moments, and pouring that tremendous whirl of energy outward into the expanding cloud, lighting it from within long after the first blast would have dimmed. The same kind of newborn heart spinning at its very fastest has even been offered as a quiet engine behind some of the brief, brilliant flashes of gamma rays that reach us from the far edges of the cosmos. If these ideas hold, then a magnetar is not always the silent leftover of a death. Sometimes, in its very first seconds, it is the reason the death shone so brightly across the universe in the first place. A tiny, furiously turning seed, briefly making one of the grandest lights there is, and then settling over the ages into the long calm that is its ordinary life. For a time, some of these objects were known by a different name entirely. Before the full picture came together, astronomers had noticed a class of strange stars that glowed steadily and oddly in X-rays, and they called them anomalous X-ray pulsars. anomalous simply meaning that they did not fit the usual rules. Two names, born of two kinds of telescope and two communities of watchers, slowly converging on one rare and beautiful truth. For a time, the soft gamma repeaters, known by their bursts, and the anomalous X-ray pulsars, known by their steady odd glow, were treated as separate puzzles, each with its own small literature, its own open questions. Only gradually did it become clear that in many cases they were the very same objects, caught in different moods or seen through different eyes, Magnetars, all of them wearing two names. There is something restful in that convergence, a quiet satisfaction in watching the catalogue of the universe grow simpler rather than more tangled. The way patient observation, given enough time, folds what looked like several separate mysteries into a single, cleaner whole, and the sky becomes a little easier to understand. The great magnetic field does not float freely. It is anchored deep in the star, its lines threaded through the crust and rooted in the churning interior beneath. When the crust shifts, even by a hair, it tugs upon those anchored field lines, twisting them, storing energy in their growing tension, the way a winding key stores energy in a clockwork spring. And when at last the strain grows past what the lines can hold, they snap into a new arrangement and release, in a single instant, all that the long centuries had stored. The whole drama, from the long build-up to the sudden flash, is a story of magnetism bound fast to matter, of invisible lines threaded through a solid shell, the two locked together and working in concert across thousands of years. It is, in its way, a machine of extraordinary patience, one that spends entire centuries loading a single spring, only to let it go in the space of a heartbeat, and then begin, without complaint, to load it slowly all over again. A mechanism whose every cycle is longer than all of human history, turning silently in the dark, in no hurry to complete even one. Detecting any of this requires a great deal of fortune. A magnetar gives off most of its light in X-rays and gamma rays, which cannot pass through the Earth's atmosphere at all. That thin, protective blanket absorbs them long before they reach the ground, which is precisely why life below carries on undisturbed. To catch them, scientists must send their instruments above the air entirely, up into orbit, beyond the protective blanket that shields the ground, into the cold and the silence where delicate detectors wait in the dark for the faint arrival of light that began its journey before human history. It is a curious arrangement when you consider it. The same atmosphere that hides these stars from us is the very thing that keeps us safe beneath it, soaking up the fierce light before it can reach the surface. To see the magnetars at all, we had first to climb above our own shelter. Every magnetar we know of has been found this way, by tireless mechanical eyes lifted clear of the world, drifting in orbit, gathering signals far too subtle and far too high in energy ever to brush the surface where you lie warm and unbothered in the dark, gathering nothing but rest. Consider, as you settle deeper, just how much energy sleeps inside the magnetic field of one of these stars. The field holds so much stored energy that it rivals or exceeds the energy of the star's own spin, which is why a magnetar can power its glow and its flares from magnetism alone, without ever drawing on its rotation the way ordinary pulsars must. Almost everywhere else in the cosmos, magnetism is a faint and secondary character in a star story, a gentle background to the great drama of gravity and nuclear fire. Here, and here alone, it steps to the front, holding more power than the great turning of a star heavier than the sun. It is a place where the invisible has become the strongest thing there is, and the strangest part is how patiently it holds that energy. It does not crackle or strain or seem eager to escape. It simply waits, for centuries, for millennia, gathering and holding its immense reserve in perfect silence, releasing it only once in a great while, in a single flare, before settling back to wait again. All that power, and almost all of the time it lies utterly still, the most energetic thing imaginable, and among the most unhurried, resting in the dark with no hurry whatsoever. Imagine, only for a moment and from perfect safety, the sky as it might look from very near such a star. The fierce gravity would bend the light of all the distant stars behind it, gathering and warping their images into bright arcs and rings. Constellations would stretch and bow around the dark sphere at the centre. Stars that should sit far apart would be drawn near, and a single point of light hidden directly behind the sphere might wrap itself into a luminous ring, a perfect halo of brightness encircling the dark centre. The whole sky would seem to flow and curve, as though seen through a vast lens of clear, still water, every distant sun bent gently out of its true place, and all of it would shift ever so slowly as the star turned beneath it. It would be one of the strangest and most beautiful skies imaginable, the entire cosmos gently rearranged by the sheer weight of one small turning world. You need not ever go there to hold the image. It is enough here in the warmth of your bed, with your eyes already closed, to let that bending sky bloom softly in the mind for a moment, and then let it fade, the way the shapes behind closed eyelids gather and dissolve as sleep draws near. The magnetic poles of such a star rarely line up with the axis it spins around, and that small mismatch is what makes a neutron star into a kind of cosmic lighthouse. Picture the great lamp of a coastal beacon swinging its light around through the night fog, brushing each passing ship in turn. As the star turns, its magnetic poles swing around with it, and any beams of energy streaming from them sweep across the sky in just that way, only across the gulf of the galaxy, the beam coming round once every few seconds and brushing now and then this small blue world. If one of those beams happens to fall across the Earth, an instrument catches a faint pulse each time it comes around. A flicker, then dark, then a flicker again, steady as a resting heartbeat, marking out the turning of a star no one will ever visit. The pulses can be so regular that they arrive almost exactly on schedule for years on end, as dependable as any clock ever built, a beacon with no keeper and no shore, turning faithfully in the dark, sending its signal toward a planet it will never know is listening. There comes a point, far along in a neutron star's life, that astronomers quietly call the death line. As the star spins down and its magnetic field fades over the ages, it eventually crosses a threshold beyond which it can no longer produce its bright beams and pulses, and it goes dark to our radio telescopes, not destroyed, simply silent, like an ember that has cooled past the point of glowing. It is a soft and undramatic ending. No explosion, no collapse, only a gradual quieting until the star slips below the threshold of our noticing and turns on, dim and unseen, for ages more. Even the fiercest of these objects is bound, in the fullness of time, for that same gentle silence. While they still pulse, neutron stars keep time with a precision that rivals the finest clocks ever built. Their rotation is so steady, so reliable, that the arrival of their pulses can be predicted to within a tiny fraction of a second across years of observation. Some are so regular that scientists have proposed using them as cosmic timekeepers, a network of distant, spinning clocks scattered across the galaxy. There is something deeply calming in that idea, that out in the dark, far beyond any human concern, there are objects keeping nearly perfect time, ticking off the seconds with a steadiness and a constancy that no worry of ours could ever touch or disturb. They do not speed up when we are anxious or slow when we are weary. They keep their rhythm regardless, indifferent and faithful, the same tonight as 1,000 years ago. Whatever happens here, whatever is lost or feared or longed for, those distant clocks go on counting, even and unhurried, exactly as they always have. Exactly. And they will go on counting long after this night has ended, and a great many nights besides, ticking quietly in the dark whether anyone is listening or not, a constancy you can lean against, drifting now towards sleep. Return for a moment to how small these stars truly are. A magnetar would fit easily within the span of a single morning's drive, its whole surface no larger than the area of a modest city, and yet it is a whole and complete world. It has 2 poles and an equator. It has a hard, bright crust and a strange, deep interior. It has a magnetic field of its own and a slow turning that carries one age into the next. Everything that makes a star feel vast and grand has been gathered and folded into something you could very nearly hold in your gaze all at once. The way an entire sweeping landscape, mountains and valleys and far horizon can be held within a single small painting on a wall. It is perhaps the very least of all the things the sky still lets us call a star, and there is a particular tenderness in that smallness, a complete world, with everything a world requires, made compact enough to picture whole. Enormity and intimacy, the grand and the small, resting together in the same dark sphere, turning quietly out beyond every planet you could name. The gravity at the surface of such a place is so immense that to climb free of it, an object would need to rush skyward at a speed that is itself a fair portion of light's own pace. A stone let go just above that gleaming crust would strike it faster than the mind can hold. The numbers are extreme precisely because the place itself is so extreme, and yet not one part of this is anything you must feel, or brace against, or fear. It belongs entirely to a world unthinkably far away, a truth about a place so remote that it changes nothing whatsoever about how lightly your own resting body now presses into the bed beneath you. There is a strange comfort in that. The more extreme the place, the more perfectly remote it becomes, so far past anything you could reach or be reached by that it slips entirely out of the realm of things to worry over and into the realm of pure wonder, where it can do nothing but be beautiful and far away. Some of these stars hide in the crowded, glittering heart of the galaxy, where the density of stars grows thick and the dust gathers in great dark clouds. One magnetar lies remarkably close, in cosmic terms, to the enormous object at the very centre of the Milky Way, and by watching how its signals reach us through the intervening space, astronomers learn not only about the star itself, but about the strange and crowded neighbourhood it inhabits. A faint magnetic beacon, glowing near the crowded centre of everything, sends its word outward to the quiet edge of the spiral where we happen to live, and the manner in which that light arrives, how it is bent, how it is delayed, how it is dimmed by the gas and dust it has crossed, reveals to astronomers not only the nature of the star but the character of the whole strange region it has traversed. The light becomes a kind of traveller returning from a far country, dusty from the road, carrying news of where it has been. By reading it carefully, scientists learn what the journey through the galaxy's dense and glittering heart was like, mapping the unseen by the marks it leaves on a single thread of light that left a magnetar long ago and only now arrives. A few of these stars do not turn entirely alone, they keep a faint companion of their own making. The particles flung from the star, hurried to great speeds along its magnetic lines, can gather in the space around it into a soft and glowing haze, a wind of charged matter streaming outward and lighting up the dark like a dim halo about a lamp seen through fog. Such a cloud is called a wind nebula, and it is woven not from the wreckage of the old explosion, but from the steady breath of the star itself, blown gently outward year upon year. To find one is to see a magnetar gilded in its own slow exhalation, a small bright sphere wrapped in a wider, fainter glow of its own particles, the two turning together in the silence. It is a quiet kind of company, not another star, not a planet, but a soft luminous cloud that the magnetar makes and holds around itself, a breath made visible, hanging in the dark wherever the star happens to wander. The youngest magnetars are often still wrapped in the glowing wreckage of the stars that made them. When a massive star explodes, it leaves behind not only the dense core but a vast expanding cloud of gas and dust, lit from within for thousands of years, a supernova remnant. Such a cloud glows for only so long before it thins and fades into the surrounding dark. To find a magnetar still nestled at its centre is to know the star is fresh, newly made, perhaps only a few thousand years old, an infant by the reckoning of the cosmos, still swaddled in the remains of its own birth. Astronomers treasure these pairings, for they reveal at a glance how young a magnetar is and how it came to be. Picture it, the great expanding shell of gas, lit softly from within, unfurling across light years like the petals of an enormous flower, opening in the slowest motion imaginable, and there at the very centre, the small dense heart that the explosion left behind, already turning, already wound with its fierce field. The newborn star and its luminous cradle still resting together in the deep, the wreckage of a death and the seed of what came after, held in the same quiet frame. The strength of these fields is so far beyond ordinary experience that the units used to measure magnetism almost lose their meaning. There is a strange comfort in numbers that large. A magnet small enough to sit in your palm, the kind that holds a postcard against a refrigerator door, carries a field measured in a small and homely number. A Magnetars field is written as a one trailed by so many zeros that the figure stops meaning anything the mind can grasp. It passes clean out of the range of anything you could hold or fear, becoming almost abstract, almost musical, closer to poetry than to measurement. You cannot truly picture such a number, and there is no need to try. The mind, meeting something so far past its scale, simply gives up the attempt and lets the figure float away, unheld, the way you might watch a single leaf carried off downstream without any wish to follow it. And in that letting go, there is rest. And through all of this immensity, there is no sound at all. Space carries no sound the way air does. With nothing to vibrate and no air to carry it, the flare that outshone the moon made no sound. The starquake that loosed it made no sound, and the great rotation, the bending of light, the trembling of the crust all unfold in a hush deeper than any you have ever known. The most violent events the galaxy can stage take place in absolute quiet, with nothing to hear them but the instruments we send and the dark itself. Picture that silence now, vast and seamless, wrapping the turning star and all the dark around it. Let it reach all the way to you now across the impossible distance, a quiet so deep and so old that it seems to gather up the small sounds of your own room, the faint hum and tick of ordinary night, and soften them and carry them away, until they too grow faint and distant and finally fade, and there is only the stillness and your breath and the dark. A neutron star that is not perfectly round can do something extraordinary to space itself. If such a star carries even the smallest bump or ripple on its surface as it spins, that lopsided turning can send out gentle waves in the fabric of space and time. Ripples that spread outward across the universe at the speed of light, stretching and squeezing the dark by amounts almost too small to conceive. Astronomers listen for such waves with instruments of breathtaking delicacy. Machines so sensitive they can register a trembling in space smaller than the width of an atom, smaller than anything that word can really convey. The thought behind it is a lovely one, worth holding gently as you drift. A bump no taller than a coin, riding on a sphere a dozen miles wide, turning out in the silence, and from that tiny unevenness, ripples spreading outward in every direction. Like a single drop falling into a still pond that has no shore, sending its rings out and out forever, growing fainter but never quite stopping. The smallest imperfection on a distant star, felt as a whisper in the shape of space itself, somewhere far away, by something delicate enough to notice. So far, no such steady whisper from a spinning neutron star has ever been heard, and there is a gentle meaning hidden in that silence. The great listening machines have strained for years toward the nearest of these stars, waiting for the faint continuous hum a lopsided one would make as it turns, and they have heard nothing. But the very fact of hearing nothing tells the watchers something true. It means these stars must be smoother even than they had supposed, their tiny mountains lower still, their surfaces rounder than the most careful guess. The quiet itself becomes a measurement, drawing the ceiling of possible roughness lower with every year of stillness. There is something restful in a science that learns from silence, that listens patiently for a sound, hears none, and takes even that absence as a kind of answer, a soft assurance that the distant star is gentler and more perfect than anyone had dared to hope. The unbroken quiet is not a failure but a finding. The stars are smooth, and the dark stays still, and the listening goes on. The bumps that could send out those ripples are themselves a marvel of smallness. On a star where gravity flattens everything to within a fraction of an inch, even a rise of a few centimetres counts as a great mountain. The grandest peak on a magnetar might stand no higher than a stack of a few coins laid one upon another, a summit you could rest your palm flat across, lower than the lip of a teacup. The toughest substance in existence, that crystalline cosmic iron, can bear up nothing taller before the crushing gravity drags it level once more. It is a world where the entire difference between a level plain and a great mountain range is the width of a thumb, where the boldest landscape is gentler than a ripple on still water, and the wonder of it is that even such a vanishing unevenness, riding on so dense a star, can make itself felt clear across the cosmos in faint tremors of space itself. The smallest rise imaginable, on the smoothest world imaginable, speaking softly to the whole universe, and all of it far too far away and far too gentle to ever be anything to you but a thing to marvel at as you drift. The magnetic field, churned by the star's restless interior, may twist over time into great ropes and coils, winding tighter as the ages pass. It is this slow winding and twisting that stores the energy later released in flares, the field coiling like an enormous spring beneath the crust, gathering tension across centuries. Picture a great skein of invisible thread, wound and wound by unseen hands, tightening turn by turn across the centuries until it can hold no more, and then, in a single instant, releasing, springing into a new shape and pouring out in one bright unwinding all the energy that the slow winding had stored. This is the deep rhythm of the field, a long, silent gathering of tension, measured in centuries, and then a rare and sudden letting go, measured in fractions of a second. The gathering is everything, the release is the briefest punctuation. So unhurried is the cycle that it makes the turning of our own seasons, our springs and winters wheeling past, seem frantic and hurried by comparison. The star is in no rush to release what it holds. It winds and waits and wins, and only once in a great age lets a little of it go. An astronomer can read the rough age of a magnetar from the way it spins. A young one turns relatively briskly and slows quickly. An older one has wound down to a longer, more leisurely rotation. By comparing the spin rate to the rate of slowing, scientists can estimate how many thousands of years the star has been turning since its violent birth. A clock written in rotation, ticking down across the ages. It is a humble and elegant kind of timekeeping, to learn the age of a thing 50,000 years of light away simply from how quickly it is forgetting how to spin. The way you might guess the age of an old wind-up music box by how slowly and reluctantly its melody now turns, how the once bright tune has stretched and softened, so too the age of a star, read in the gradual slackening of its rotation, a clock that tells its own time. These flares can be so bright that they are sometimes seen from entirely different galaxies. A giant flare from a magnetar millions of light years away, in another island of stars separated from us by a void so wide that our whole Milky Way could be lost in the crossing, can still arrive at the Earth as a brief flash strong enough to be noticed and measured, the faintest pulse, gone before it has well begun, and yet bright enough at its source to register, for a fraction of a second, on instruments built to wait for it. To catch such a thing is to glimpse one of the rarest objects in the universe, living its rare life in a galaxy other than our own. It is a humbling and a comforting thought together, that these wonders are not ours alone, not confined to our small corner, but scattered sparsely and beautifully throughout the whole of creation, turning in galaxies we will never reach, flaring once in an age into a dark that carries the news, faintly, to anyone anywhere with eyes delicate enough to gather it in. The same magnetism that runs so wild in a magnet runs gently and faithfully here at home. The Earth carries its own modest magnetic field, the one that guides a compass needle and shields the planet from the wind of the sun. And when that wind stirs the field, it spills light into the night sky as the auroras, those curtains of green and rose that ripple over the poles. A Magnetars field is that very same kind of thing, the same force you can feel in the soft tug of two small magnets drawn together in your palm, only made unimaginably, immeasurably mighty. There is no new and exotic power at work in a magnetar. It is simply the familiar magnetism of everyday life, carried to an extreme the mind can barely follow. The aurora and the magnetar are kin, near relations born of one simple law, one a tender veil of green and rose rippling over a still northern night, the other the fiercest magnetism in all the universe, 50,000 years away. The same gentle thread, drawn out to its very limit, and drawn out only a little, glowing over a snowfield at home. Because these conditions can never be made on Earth, a magnetar serves as a kind of natural laboratory, suspended far away in the dark. There are questions about matter, about magnetism, about the deepest behaviour of light that no instrument human hands could ever assemble would be strong enough to settle. And yet the cosmos has already set the experiment running, out there in the silence, with no need of us at all. Each magnetar is a vast and unhurried demonstration of physics carried to its very edge, conducted for no audience, set running for thousands of years, available to any mind curious and calm enough to look. There is only the watching left to do. The universe, it turns out, performs its hardest and most extravagant experiments entirely without fuss, in the dark, with no one obliged to attend, content to run them unwitnessed for an age, until someone somewhere eventually thinks to lift their eyes and wonder. Finding even one of these objects can take years of patient searching across the whole sky. Astronomers comb through vast surveys, sifting countless faint points of light, watching for the particular signature of a slow spin and a fierce field, the telltale flicker of a starquake's flash. Most of the sky holds nothing of the kind. The magnetars are needles in a haystack the size of the galaxy. And yet, one by one, across the decades, they are found. Each discovery the fruit of long attention and longer patience, a small triumph of simply continuing to look. There is a quiet lesson in that, drifting at the edge of sleep, that some of the rarest and most beautiful things reveal themselves only to those willing to wait a very long time in the dark. Like all warm things left in the cold, a magnetar slowly cools across the ages. It is born ferociously hot in the fire of the supernova, and over thousands and millions of years it radiates that heat away into the surrounding dark, dimming by degrees, its glow gradually softening. The cooling unfolds over spans beyond easy reckoning. The star will go on shedding its warmth long after the magnetic fury of its youth has faded entirely, dimming by the faintest degrees, settling toward the deep cold of space across stretches of time that dwarf the whole age of our species many times over. Think of an ember pulled from a great fire and set down alone in a cold and windless room. It glows brightly at first, then duller, then a deep red, then only a memory of red. And the dimmer it grows, the longer each further dimming takes. So it is with the star, but stretched across the better part of cosmic history. A single ember banking down through the dark over millions upon millions of years, never quite reaching black, in no hurry whatsoever to surrender the last of the heat it was born with. The most leisurely cooling imaginable, a warmth let go so gradually that the letting go itself becomes a kind of permanence. To stand upon such a star is impossible, and that impossibility is itself a kind of peace. No ship could ever land there, no hand could ever brush that gleaming crust. The gravity alone would forbid any approach, and the field would forbid it twice over. It is a place that exists wholly beyond our grasp and always will, a world made only to be beheld from a great distance, never visited, never altered, never disturbed by anyone. And there is something deeply restful in a thing so perfectly out of reach. It cannot be claimed, or spoiled, or hurried, or asked to be other than it is. It simply exists, turning in the dark exactly as it has for ages, and will for ages more, whole and complete in itself, the most serene of all the things that no one will ever touch, and the freer, perhaps, for being so. The names these stars carry are plain and practical, a quiet code among the people who study them. A magnetar might be called by letters and numbers that mark the kind of object it is and the precise spot in the sky where it was found. A soft gamma repeater here, an anomalous X-ray pulsar there, each followed by a string of digits that pin its place against the dark. There is no poetry in the labels themselves, and yet there is a quiet tenderness in the care those plain codes represent. Each string of digits is a small promise that this faint and unthinkably distant thing, glimpsed once across the gulf of half a galaxy, has been noticed, located, written down, and remembered. It has been given an address in the great catalogue of the sky, so that anyone who wishes may return to that exact spot and find it again, and watch it, and slowly come to understand it. There is something touching in that across all the emptiness a few people troubled themselves to give a name and a place to a thing that will never know it was named, simply so that it would not be lost again, simply so that it could be found and cared for. There is a strange and lovely truth hidden in the great distances involved. To look outward into space is always, unavoidably, to look backward into time. The light reaching any instrument tonight is old light, set out long ago, and the further the source, the older the news. So the magnetar you might picture is not the star as it stands now, in this present moment, but the star as it was on the day that light first set out, 50,000 years ago, in an age long before any chronicle was kept, before the first written word, before anyone had thought to name a single star. In the ages the light has spent crossing to us, the star itself may have shifted, faded, perhaps already mellowed into a quieter neutron star. Its present is forever sealed away from us behind the long delay. You can never know its now, only its long ago. Every magnetar is therefore a kind of preserved memory, a portrait of a distant past arriving faithfully in the present, true to how things were and silent about how they are. A letter from long ago asking only to be read, asking only to be seen. The fierce field does more than glow and flare. It shapes the very motion of the particles around the star, channeling them along its invisible lines like water guided through unseen pipes. Charged particles cannot cross the field freely. Instead, they are funneled and steered, flowing along the great magnetic arcs, gathered toward the poles, woven into the beams that sweep the sky. The whole near space of the star becomes an intricate, invisible plumbing of magnetism, every particle following its appointed line. It is a hidden order of immense subtlety, written in forces no eye can see, organising the chaos of a star's surroundings into something patterned and almost serene. Now and then, against the steady slowing, a neutron star will do something small and surprising. It will suddenly speed up, just a little, in an event astronomers call a glitch. After ages of patiently winding down, the star's rotation hiccups faster for an instant, then resumes its gradual slowing, a tiny stumble in an otherwise perfect rhythm, thought to come from the strange frictionless ocean within, briefly slipping against the crust above it and lending the surface a faint push. These glitches are minute, far too small to notice in any ordinary way, betrayed only by the most precise timing of the star's pulses, where the steady arrival suddenly runs a hair ahead of schedule. Picture a great wheel turning evenly for age upon age, and then, just once, giving the faintest forward jump before resuming its even turn as though nothing had happened. That is a glitch, the single subtlest irregularity in one of the most reliable rhythms anywhere in the cosmos, like a single skipped beat in a song that has been playing, unbroken and unhurried, for 10,000 years, and that returns at once to perfect time. Even the steadiest things, it seems, are allowed one small stumble now and then, and lose nothing of their steadiness for it. It is worth remembering how recent all of this knowledge is. For nearly the whole of human history, no one had any idea that such objects could exist. The very concept of a magnetar was first sketched out only a few decades ago, well within a single human lifetime. The people who first imagined them are, many of them, still alive. We are among the very first generations ever to know that such objects exist at all. For the whole long stretch of human history, through every civilization, every lifetime, every night that anyone ever lay down to sleep beneath the stars, no one had the faintest idea that the dark held these things. The shepherds who named the constellations did not know. The great astronomers of past centuries charting the heavens with such care did not know. To lie here tonight aware of them, picturing one turning quietly tens of thousands of light years away, is to hold a piece of understanding that almost no human being who ever lived has shared. A brand new wonder, freshly added to what our kind knows of the sky, and yours to rest with freely tonight. The reason none of this fierce energy ever troubles the Earth is itself a comfort worth dwelling on. Our planet is wrapped in a deep blanket of air, and that blanket absorbs the X-rays and gamma rays from space long before they can reach the ground, soaking them up high overhead, far above the weather, where they can do no harm. Even the mightiest flare yet measured, that great burst of 2004, reached no deeper than the topmost edge of that blanket and left the world beneath it wholly undisturbed. Think of the atmosphere, then, as a soft and faithful guardian wrapped around the whole planet, drinking in the harsh light of the universe so that the surface stays calm and warm and safe. Beneath it, you have always been protected. Beneath it tonight, you're free to let go and rest, with nothing fierce able to reach you, and there is a further mercy in sheer distance. For a magnetar's fury to so much as stir the air of a planet, the star would have to lie almost impossibly near, closer than any neighbouring sun, a near neighbour in the same small pocket of space. Yet every magnetar ever found lies thousands upon thousands of light years away, off across the wide wheel of the galaxy, with whole oceans of empty space between. Not one of them sits anywhere near our quiet corner. Not one ever has, in all the time the Earth has turned. The nearest is so far that its fiercest flare arrives here gentler than starlight, and the stars themselves are gentle. So you may rest in a doubled safety tonight, sheltered by the air above you, and sheltered by a gulf so vast that none of these distant furnaces could ever be more to you than a far and harmless wonder. A magnetar holds a particular place in a small family of strange remnants the universe leaves behind. Lighter stars, like our own sun will one day be, fade gently into white dwarfs, glowing embers about the size of the Earth, cooling for ages. Heavier ones leave behind the dense city-sized neutron stars, among which the magnetar stands as the most fiercely magnetic of all, a rare and dramatic variation on a theme already extraordinary. And the very heaviest of all may collapse further still into something from which not even light escapes. To know where the magnetar fits is to see the whole quiet order of stellar death laid gently out before you. Not a catalogue of disasters, but a set of resting places, the many different ways a star is allowed to come to its end. Each one is beautiful in its own right, and each is, in its way, a kind of peace, the long, calm afterlife of a light that once blazed. For all the magnetars that have been found, many more may be turning unseen in the dark. The galaxy is thought to hold far more of them than the few dozen so far catalogued. Countless old magnetars whose fierce magnetic youth has long since faded, now drifting quietly as ordinary neutron stars, and perhaps younger ones still hidden behind the thick dust of the galaxy's crowded lanes. The known magnetars are only the fortunate handful that happened to flare while someone was watching, or to aim their sweeping beams across our small corner of space. For every one we have found, many more are surely there. They give no sign we can yet catch, and so they go uncounted. But they are there all the same, turning in the dark, a vast and hidden population of spent and cooling stars filling the galaxy with silent company. The sky you might picture overhead is far more crowded with these gentle remnants than the short list of the discovered would suggest. A great unseen multitude resting quietly, keeping the dark from ever being truly empty. Not every magnetar wears its strength on the outside. Astronomers have found a few stars that by the usual measure, the gentle slowing of their spin, seem to carry only a modest field, no fiercer than an ordinary neutron star's, and yet now and then they let slip the same bright flares that mark their mightier kin. The likeliest answer is that the great field in these quiet ones is folded away inside, wound deep within the star in tight hidden coils, while only a milder field reaches the surface to show itself in the spin. The fierceness is there. It is simply tucked out of sight, buried in the interior like a strong current running beneath a calm and unremarkable surface. These gentle-seeming stars blur the old tidy line between a magnetar and a plain neutron star, suggesting that many an ordinary-looking remnant may carry a sleeping strength within, betraying it only rarely in a single soft flash before falling quiet again. It is a tender thought to drift off on, that great power need not always announce itself, that it may rest hidden and unspent inside something that looks, from the outside, perfectly calm. The heat within such a star does not sit still. It moves slowly through the crust and across the surface, redistributing itself over long spans of time. The intense magnetic field even guides how that heat flows, channeling warmth more easily along certain directions than others, so that the surface may glow a little warmer at the magnetic poles than along the equator. The whole star is a slow, silent exchange of heat and magnetism, every part in quiet conversation with every other, settling toward balance across the centuries. It is an object utterly without hurry, taking thousands of years to do what a warm stone by a hearth does in an evening, easing its warmth gently from one place to another in the dark. To witness a giant flare with one's own instruments is the rarest of privileges, granted perhaps once or twice in a scientist's working life. An astronomer might watch the sky for decades and catch only a single one, or none at all. The few who were watching in 2004 when the great flare arrived count themselves fortunate to have been at their instruments in that exact fraction of a second. It is a reminder of how much of the universe's grandeur unfolds with no witness at all. Vast events bloom and fade in the dark of space every day. Flares, collisions, the births and deaths of stars. The overwhelming majority of them seen by no one, recorded by nothing, simply happening and then over, as they have for billions of years. The flare that reached us in 2004 had crossed 50,000 years of emptiness, and it brushed our instruments for a fifth of a second. A moment earlier or later in all that vast span, and the few who caught it would have been looking elsewhere, and it would have passed unseen like nearly all the rest. That is what makes the catching so precious. A single thread of the universe's endless private life, glimpsed by chance and treasured for having been glimpsed at all. The endurance of these stars stretches past anything the mind can hold. Long after our sun has swelled and dimmed, long after the constellations we know have drifted into new and unfamiliar shapes, the neutron stars that magnetars become will still be turning in the dark, cooling ever so gradually toward the cold. They are among the longest-lived things the universe makes, quiet, dense survivors that will outlast nearly everything around them. To picture that span is to feel your own small worries grow lighter, set against a thing that will endure for so unimaginably long that the entire history of life on Earth is, beside it, a single afternoon. To bring the field's strength once more to something you might have seen, consider the great machines in hospitals that look inside the body using magnetism, the ones that hum and knock while a person lies still inside them. Those machines hold some of the strongest steady magnetic fields ever made by human hands, strong enough to tug a wrench across a room, and a magnetar's field is many trillions of times stronger still. So far beyond the mightiest magnet our whole civilization knows how to build that the gap cannot really be crossed by the mind. It is a gap so wide that it loops all the way back around into a kind of calm. For if the fiercest magnetism in the universe lies that unreachably far beyond anything that could ever exist here, then the forces of our own world are revealed as wonderfully, mercifully gentle by comparison. The soft pull of a magnet holding a note to a door, the faint tug that turns a compass, the quiet magnetism woven all through ordinary life, none of it ever more than the body can easily bear. We live, it turns out, in a place where even the strong forces touch us softly, and tonight you are free simply to be still and let it hold you. The crust of a neutron star may be in a sense a single vast crystal. The cosmic iron is thought to arrange itself into an ordered lattice of staggering regularity, every nucleus sitting in its proper place, packed in a pattern that repeats unbroken across the whole shell. It is as though the entire surface of the star were one perfect, flawless gem, miles across, gleaming faintly in the dark. No jeweler made it. It grew of its own accord in the cooling aftermath of a dying star, settling into order under unimaginable pressure. Think of the most perfect crystal you have ever seen, a single clear facet catching the light, and then swell it until it wraps an entire world. That is the crust, the largest and most orderly crystal the mind can conceive, a planet-sized jewel turning in the silence. There is a deep serenity in that image, something the eye wants to rest upon. A whole world sheathed in a single seamless crystal, every atom exactly where it belongs and content to stay there. Nothing out of place, nothing in need of fixing, perfect order holding itself together in the dark. The fierce environments around these stars may help fling certain particles across the galaxy at tremendous speeds, the fast-moving fragments of atoms that rain gently and constantly upon the Earth from all directions, known as cosmic rays. The great magnetic fields can act like vast natural accelerators, hurrying particles to enormous energies before casting them out into the dark to wander the galaxy for ages. Some of those wandering particles eventually find their way down through our sky, harmless and entirely unfelt, a faint and constant sprinkle arriving from the deep. They have been travelling for ages, flung out long ago from the fierce places of the cosmos, wandering the galaxy along curving magnetic paths before chancing at last upon our small world. And even now, as you lie still in the dark, a few of these travellers are passing softly through the room, through the walls, through the air, through you, leaving not the faintest trace of their passage. There is something almost companionable in the thought that the violent distant places of the universe send these tiny silent messengers drifting gently through your resting body, ancient and harmless, a quiet rain from the stars falling through you while you sleep, asking nothing, disturbing nothing at all. These same fierce surroundings may quietly manufacture something rarer still, the mirror image of ordinary matter. In the intense fields close to such a star, where light itself can turn into matter, particles can be born in matched pairs, an ordinary speck and its opposite twin, alike in every way but reversed, the kind of thing physicists call antimatter. Some of the faint drift of these mirror particles that wanders through the galaxy may have been forged in places like these, near the most magnetic stars there are, then set loose to roam the dark for ages. It is a gentle marvel to consider as you settle, that out in the silence the universe spins not only the familiar stuff of stones and stars, but its strange reflection too, and that a little of that reflected matter may be drifting even now through the great quiet between the worlds. Born in the fiercest places, it travels in perfect calm, harmless and faint, one more soft and ancient traveller moving through the dark while you lie still and warm and far away from all of it. There is a gentleness built into distance itself. The light of that great 2004 flare left its star blindingly, impossibly bright, and yet spreading outward as it crossed the immense dark, thinning across 50,000 years of emptiness the way ripples flatten as they widen across a pond. It arrived here as the faintest of touches, a brush against the high edge of the sky and no more. Distance is a kind of mercy when you think on it. A flame that would blind you in the same room is only a warm and pretty point of light seen from across a dark valley. A shout that would startle you up close softens to almost nothing over a far enough field. The farther a thing lies, the more softly it can ever reach us. Distance takes the fiercest events the universe can stage and renders them gentle simply by the width of the gulf they must cross, until even a titan's roar, after a long enough journey, arrives as nothing louder than a whisper, and then as silence, and then as rest. Because their rotation is so steady, Magnetars and their kin may one day help test the deepest laws of nature. By comparing the precise ticking of these distant clocks across the years, scientists can search for the faintest signs of change in the fundamental constants of physics, the unchanging numbers that govern how the universe behaves. So far, those numbers appear as steady as the stars that help measure them, holding firm across the ages. There is a profound reassurance in that constancy, that beneath all the turning and flaring and cooling, the basic rules of the cosmos hold perfectly still, the same here as 50,000 light-years away, the same tonight as 10,000 years ago. A spinning star can sway as well as turn, ever so faintly, the way a child's top traces a wide circle with its tilted stem even as it spins. The axis a neutron star turns around may itself drift around in a long gradual loop over the years, a gentle nodding the astronomers call precession, so that whatever beam it throws drifts in its aim by the smallest degrees across great stretches of time. It is one more layer of motion laid softly atop the turning, a slow circle traced around the quick one, the rapid spin cradled inside a far longer sway that might take years to come round even once. The whole star moves in the dark like a vast deliberate pendulum, keeping time in more ways than one at once, every one of its motions measured and even, none of them hurried, none of them able to be rushed by anything, turning and nodding and turning again, with all the time in the universe to do it. The pace of discovery is itself a quiet rhythm. Across the years, astronomers tend to find a new magnetar every so often, perhaps one or two in a year, sometimes after long stretches of finding none. Each addition to the small catalogue is celebrated quietly, studied carefully, and slowly woven into the larger understanding. The list grows by ones and twos, never in a flood, mirroring in its own way the patient, infrequent rhythm of the stars themselves. It is a science of waiting and watching, of long attention rewarded now and then by a single faint new point of light, added gently to the roll of the known. Some magnetars are born among siblings, in great clusters where many massive stars form together, dozens or hundreds at once, condensing from the same vast cloud like a brood born in a single season. They blaze fiercely and briefly, the most massive burning through their lives the fastest, and one by one they die. The magnetar is what one of them leaves behind, and it endures long after its brilliant brothers and sisters have faded from the sky. There is a quiet poignancy in that thought, a single dense ember outlasting all the bright stars it was born beside. It keeps a long, faithful vigil in the place where a whole nursery of suns once shone, the cluster slowly dispersing around it, the bright companions gone to their own ends. And still the magnetar turns, the last and most enduring child of a long-scattered family, holding its place in the dark, carrying on alone with a steadiness that asks for no company and grieves for none, simply continuing quietly where so much light once was. Gather all of it together now, and what remains is a kind of order. For all the talk of fierce fields and titanic flares, a magnetar is, at heart, a thing of profound regularity, a sphere turning with the steadiness of a perfect clock, glowing with a patient warmth, governed in every motion by simple and unchanging laws. The drama is rare, the order is constant. Beneath every flash and every starquake lies a turning so reliable that the whole object becomes a kind of lullaby written in light and motion, a slow, even measure kept across the ages with no faltering and no haste. It does not rush, and it does not stop. It turns at its appointed rate, glows at its steady warmth, obeys in every motion the same simple rules that govern a falling leaf or a swinging compass needle here at home. There is profound comfort in that dependability, in a thing so powerful that is also so perfectly governed, so utterly without caprice. The lullaby plays on, sung to no one in particular across the empty dark, asking for no listener, and yet it arrives, faintly, here, in this room, where you lie growing heavier and warmer and further from the cares of the day, carried gently down by a rhythm older than the earth. The colours a magnetar paints, were your eyes able to gather the light it favours, would lie far past the familiar arc of the rainbow. The light your eyes can gather is only a thin slice of all the light there is, a single octave in an immense and silent music. Below the red, you know, lies warmth you can feel on your skin but never see. Above the deepest violet stretch rung upon rung of energies, ultraviolet, then the X-rays, then the gamma rays, an entire ladder of light climbing upward, invisible to you but plain to the instruments built to see it. The magnetar shines most brilliantly up there, in those highest reaches, in hues no human being has ever witnessed or ever will. Picture, drowsily, a colour you have no name for and could never quite bring before your eyes, and know that the star is glowing in exactly that, steady and bright, tens of thousands of years away, forever beyond the small bright window of human sight. It is a quiet thing to rest with, that the universe glows in colours we cannot see, all around us all the time, and that we are none the poorer for it, and the dark none the less beautiful. The light a magnetar sends out can carry the mark of its fierce field written into it. Rising from the surface and crossing the fiercely magnetized space around it, the light can be gently turned and aligned by the field, carrying away upon it a faint and orderly mark, a fingerprint of the magnetism it passed through on its way out. And careful instruments, reading the way the light is oriented when at last it arrives, can recover from that mark the shape of a field tens of thousands of years and tens of thousands of light years away. It is a message written not in the brightness of the light, nor in its colour, but in its hidden grain, in the quiet alignment of the light itself, a kind of handwriting, the very polarization of ancient light that only delicate machines can read. The star, without meaning to, signs its light with the shape of its own invisible field, and that signature crosses the whole width of the dark to be decoded gently here, long after the writing, by minds curious enough to look for it. A magnetar takes its place in a long unbroken chain of cosmic giving. The massive star was forged from gas gathered across millions of years. It lived and died and scattered new elements into the dark. From its death came the magnetar, and from the scattered gas would come new stars, new worlds, perhaps in time new life to look up and wonder. Nothing in this story is wasted. Nothing simply ends. The matter only changes its form and passes on, from cloud to star to remnant to cloud again, in a slow and patient cycle that has turned for billions of years. The magnetar is one bright link in that chain, holding its place in the dark, part of a turning far larger than itself. Consider how much of a magnetar's existence is spent simply waiting. Between one flare and the next may lie centuries of perfect quiet. Between one starquake and another, ages of unbroken stillness. The dramatic moments strung end to end would account for the merest sliver of its long life. All the rest is patient turning in the dark, gathering strain too slowly to see. If a life could be mostly rest, punctuated only rarely by a single bright event, then a magnetar lives such a life, and there is something deeply reassuring in that, drifting here at the edge of sleep, in a thing whose natural state, for all its power, is simply to be still and wait. The discovery of these stars rewrote what astronomers believed was possible. Before the magnetar, no one had imagined magnetism could climb so high, that a field could grow so strong it would reshape atoms and bend the behaviour of empty space. The finding pushed back the boundary of the known, showing that the universe holds extremes far beyond what anyone had dared to picture. And that too is a quiet comfort. The knowledge that the cosmos is wider and stranger and more generous with its wonders than we ever assume, that there are surely marvels still waiting, out past the edge of what we now know, patient and undiscovered in the dark. Even the way a magnetar dies into ordinariness is gentle. There is no instant you could point to and call the ending, no final cataclysm, no last great flare, no collapse, only a long, smooth easing, one age blending into the next so gently that the boundary cannot be found at all. The field weakens by imperceptible degrees. The flares come less and less often, and then no longer come at all. The glow eases downward toward the deep calm of an ordinary neutron star. The fierce star and the quiet star are the very same star, only further along its road. It is the softest kind of conclusion imaginable. Not a door slammed shut, not a candle blown out, but a light turned down by the smallest amounts across uncountable years, a fury laying itself down of its own accord and settling into a long and untroubled rest. Everything fierce in the star is allowed, in time simply to grow calm, and there is in that a quiet promise worth carrying down towards sleep, that even the most intense things are permitted at the last to soften and to rest. Somewhere out there even now, the parents of future Magnetars are burning, massive, brilliant stars still living out their brief and luminous lives, all unaware of what they will one day become. Ages from now, long after this night and everyone who shared it have gone to their own rest, those stars will reach the end of their fuel and collapse and leave behind new, dense magnetic hearts to turn in the black where they once blazed. The story of these objects is not a finished one, set down and closed. It is still being written, very slowly, in stars not yet collapsed, in fields not yet wound to their fierce strength, in light not yet set out on its long crossing of the dark toward whoever might someday be lying quietly as you are now looking up. The universe is still making magnetars. It will go on making them long after us. And there is a deep and restful humility in that, to be one small, warm, waking witness, for one night, to a story so much longer than ourselves, a story we may simply rest easy inside for a little while. And here is perhaps the most consoling thought of all. Every magnetar, for all its staggering power, harms nothing across the vast and empty distances that separate it from everything else. It turns alone in the dark, pouring out its fierce light into space where there is no one to be troubled by it, flaring once in an age into emptiness that simply absorbs the light and carries on. Its power is real and immense, and it is also, in the great loneliness of space, utterly without consequence for you, a force of titanic strength expended entirely upon the indifferent dark, leaving the small warm world where you rest completely undisturbed, now and always. So let the final image be the simplest one, a single dense sphere, no wider than a quiet town, turning slowly in the deep dark 50,000 years away, wrapped in an invisible magnetism finer and stronger than anything the mind can hold, glowing with an even warmth, keeping perfect time. It asks nothing of you. It needs nothing from you. It does not know you are watching, and it would turn exactly the same if you were not. There is a deep peace in being for this one night, only a witness to something so vast and so far and so beautifully indifferent, held, along with all your cares, in the great soft dark that surrounds it. You have come a very long way tonight, out past the planets and the scattered stars, to the rarest and most magnetic objects the universe knows how to make. There is nothing left to reach for now. The turning star will keep its time without you. The dark will hold it, and hold you, exactly as gently as it has all along. And if you are still here, floating at the soft edge of sleep, another quiet journey is already waiting for you on the screen, ready to carry you onward through the dark whenever you wish, or never at all. There is nothing you need to choose. It will wait as long as you like. For now there is only this, the heaviness of your own resting body and the slow turning far away. You do not need to carry any of it with you into sleep. Not the numbers, not the names, not the great fields or the distant flares. Let all of it loosen now, the way the hands open in sleep without being told to. The facts have done their quiet work. You may set them down. What stays will stay on its own. What slips away was only ever passing through. Feel the weight of your body now, settled and warm, far from the cold and the distance, here in this safe and ordinary dark. The star is turning 50,000 years away, and you are resting here, where nothing immense can reach you. Let your breath grow slower. Let your thoughts grow dim, one by one, like faint lights going quiet at the edge of a wide field at night. There is nothing more to know. There is nowhere else to be. There is only the soft dark and the warmth of where you lie, and the slow easing of everything you are holding. Let it go now. Let yourself grow heavy. Let the long night close gently over you, like a tide coming in. And now, 101 wonders are resting with you. Sleep now. Good night.